So you've just run a scan on a network, and you've got this wall of data, open ports, services, all sorts of information. What do you do with it? Well, that's what we're here to talk about. We're going to learn how to take that raw data and turn it into real, actionable intelligence. It's about moving from just seeing what's there to truly understanding the risk.
Think about it this way. A port scan shows you all the doors into a system. But, just because a door is there doesn't mean it's a problem. The real question, the one we're here to answer, is that door unlocked? Is the lock broken? Can somebody just waltz right in? That's the heart of vulnerability analysis.
All right, here's our game plan. First, we'll see how a tiny clue from a scan snowballs into a confirmed vulnerability. Then, we're going to learn the secret language of weaknesses, decoding things like CVEs and CVSS scores. After that, we'll open up the toolkit and look at how hunters actually find these flaws. And finally, we'll bring it all together to talk about risk and defense.
Okay, let's jump right in. This first part is all about that initial moment of discovery. It's about taking one little piece of data from a scan and realizing, hey, wait a minute, this could be something. This is where the real investigation begins. This is the classic workflow, and it makes perfect sense. You start with a port scan to find those open doors. Then, service detection tells you what's running behind the door. Is it a website, a file server? And this is the most important part. Step 3 is version identification. It's not enough to know it's an Apache web server. You need to know it's Apache version 2.4.49. That very specific number is the key that unlocks everything else.
So what exactly is this vulnerability we're looking for? Well, it can be a lot of things. A bug in the code, a simple mistake in the setup, or maybe just software that's super old and hasn't been updated. The bottom line is, it's a weakness. It's a flaw an attacker can use to their advantage. It is, quite literally, a broken lock on one of those doors.
Now, when we find these broken locks, we need a way to talk about them, right? Security pros all over the world need a common language, and that's exactly what CVEs and CVSS are for. They're a standardized system to name these flaws and measure just how bad they are.
First up is the CVE. Think of a CVE ID as a unique serial number for a single, publicly known vulnerability. It's like the model number for that specific broken lock. So if you tell another security person CVE 2021-44228, they know exactly what flaw you're talking about. No confusion. Okay, so the CVE tells us which lock is broken. But what about how broken it is? I mean, is it just a little tricky to open, or will it completely fall apart if you look at it the wrong way? That's what the CVSS score tells us. It's a scale from 0 to 10 that rates the severity of the vulnerability.
And this score is what drives action. You see, anything below a 4 is pretty low priority. From 4 up to about 7, that's a medium risk, definitely something to look at. But when you see a score of 9 or 10, that's a critical vulnerability. Those are the ones that make defenders drop everything, because they're often the easy, wide-open doors for attackers.
All right, enough with the theory. Let's get our hands dirty. How do we actually go from having a software version number to finding out if there's a CVE for it? Let's pop open the toolkit. Honestly, the simplest method is sometimes the best. Once you have that version number, just Google it. Seriously, typing something like Apache 2.4.49 CVE into a search engine is your first and often most powerful move. You'll get tons of results, security bulletins, databases. Your job is to read through them and figure out what the real impact is.
Now, if you want a more targeted approach, there are awesome tools like Searchsploit. It's a command line tool that comes with Kali Linux, and instead of searching the whole internet, it searches a local database of known exploits right on your machine. This is super fast and gets you straight to the good stuff, the actual code that might be used to attack the flaw.
Now, when you find some code, you have to know what you're dealing with. There is a huge difference between a proof of concept, or a POC, and a reliable exploit. A POC just proves the vulnerability is real. It might be clunky, unstable, it might even crash the target. A reliable exploit, though, that's weaponized code. It's designed to work and work well every time.
And this brings us to what is maybe the most important rule of this entire process. You never, ever, ever run code you found online on a system you don't have explicit written permission to test. It's incredibly dangerous and it's illegal. All of this research, all of this testing must be done in a safe, isolated lab that you control. No exceptions.
So let's wrap this all up into a simple workflow you can follow every time. 1. Identify the service and its exact version. 2. Search for its CVEs and any exploit code out there. 3. Evaluate the risk. Is this actually exploitable in this specific environment? And 4.
If you need to go further, you confirm your theory safely in your lab.
Okay, for our last section, let's talk about what happens after you find something. Because the real skill isn't just about finding vulnerabilities. It's about understanding their context, their actual risk, and then seeing the whole picture from the defender's point of view.
So why isn't every high CVSS score a complete disaster? Well, context is everything. That exploit you found might not work because the server has a custom configuration. Or maybe there's a firewall in the way that blocks the attack. And a lot of the time, guess what? The system admin has already applied the patch that fixes the problem. A vulnerability on paper isn't always a vulnerability in practice.
And that brings us to the other side of the coin, defense. This is what organizations are doing to protect themselves. They're doing patch management. Basically, they're fixing the broken locks we find. They're using proactive monitoring to look for any signs of an attack in progress. And they're using threat intelligence to know what new attacks are coming. Your research is what fuels their entire defensive strategy. So let's end on a quick scenario. You're doing a test, your scan comes back and tells you there's a server running Apache version 2.4.49. With everything we've just talked about, what's your immediate next step? What's the very first thing you do? This knowledge is a powerful tool. It gives you the ability to find weaknesses in systems. And with that power comes a huge responsibility to use it ethically, legally, and always with the goal of making things more secure. So hunt responsibly.